Okay. Looks like it leveled back out. It's upsetting to do like a whole stream and then... Okay. So what I have here is like a node-based programming game. Without blue. Alright, so we have ourselves two systems here we need. Can I do both? I can't do both. Go for one or the other then. If red, go here. Wait, if red, go output. If else, go here. Can this also go out? They can. Okay, so they can both go output. How do I break? Okay. If green, go here. If else, go to trash. Okay, so that's green. And a red solve. Let's test that. Red and green done. That needs to get done in about like 10 seconds. Can it get done in about 10 seconds? Yeah, looks like it. It's good enough for me. Cat Cloud. Basic machine learning, almost machine learning. Indeed. Questionnaire data. Private. History of expert systems. 1965 can be considered a starting point for the work on creating expert systems. That year, scientists of Stanford Research Institute Edward Feinbaum and Bruce Buchanan teamed up with Nobel laureate... Is that how you say that word? Laureate? Joshua Lederberg, and began working on computer systems designed to determine the molecular structure of chemical compounds. I can buy an aloe. Tree. Yeah, okay, this is the work tree. Errors in beta database. We have some errors in our questionnaire data we can solve by ourselves. Can't solve the problem by ourselves. Can you fix it? And that's this one, I think. Oh, I see. 1936, 1966. 1966, 1998. Errors in database 2. Hello, it's us again. We found some new types of errors made by our users. Please update your program. It will be easier if you will use the previous version of the code. Deep news on neural artificial intelligence. Worked horribly. 1966. Custom nodes are special nodes containing your previously designed schemes. Press on the middle tab to switch to custom nodes. Drag the custom nodes starting the color red to the workplace. Want to modify the schemes inside the custom node, double right click it, press the down arrow icon. Oh. Red else divide. Photos with cat, photos with cat, photos with no cat. Okay. I'd rather just make a whole new one. I need a node limit of 2 though. Yeah, that's cancerous. Without blue, GB divide, only red. Alright. So let me see here. What do I need to do? Output stream, I just need reds. Red else divide. Else photos with no. Yeah, I guess that works, huh? Go here. Go here. Go to trash. Yep. That works pretty well. Green-blue divide without blue. I'm okay with saving my own nodes and stuff. Cat Cloud. Is there like a place I can go to design my own nodes? Liza, world's first chatbot. So cute. Decision tree. Medex optimization. Illuminati origins. I recognize a cat in the picture. That's me! Anywhere to detect the cat without using expert systems. It works for text, but with pictures, not so much. Furthermore, that cat just won't sit still. With that it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable around them, try Sift. This little devil is way more effective with pictures, also works nicely when paired with other algorithms. You can use nails or glue or something. Come on, it's just a cat. We'll fight you back. Different nodes have different processing rates. I see. This parameter will influence efficiency of your schemes. Icons on the right indicate the amount of time required for a node to process one element. Decision tree color. The node compares output parameters, the sockets, of an element's color. If the element color is equal to only one socket's color, the element moves to that socket. Element's color class satisfies both conditions or none of them, it goes to a random socket. Decision tree is one of the basic machine learning algorithms. Each tree knows a limited number of classes. For each element, the tree asks some questions and chooses the class most similar to the element. Wonder how it works. Math, integrals, other scientific words. Sounds like a hell on earth. There's a red-blue tree divide, so red-blue. Does greens also go for reds? Node compares output parameters of sockets with element's color. The element color is equal to only one socket color, the element moves to that socket. Okay, I need red-green here, and blue-green here. Oh. So... yeah, I guess I need this one and this one. Too many nodes. Does this just work by itself then? Red. Could I just switch this to any? Yeah. Well, now I can't get green up there. Blue. Does it split them equally? No. Oh, it does. Okay, never mind. Jeez. MedX, crowd psychology, optimization, Pizza Shack, Chicken Escape. Optimization of the code. Hi, it's us again. What's our last request for you? We've changed our database system. Can you update your code one last time? We need to work faster. Thanks. Who invented the decision tree? Decision tree is one of the automatic data analysis methods. The first ideas of creating decision trees date back to the worlds of Hovland and Hunt in the late 50s and 20th century. However, the fundamental work that gave impetus to the development of this... Impetus? Is that a word? The development of this direction was a book named Hunt, Marin, and Stone Experiments in Induction, published in 1966. Let's optimize. To decrease and increase speeds, click a button on the screen or use the arrows. Yeah. Only read fast. Oh, that's right. Decision trees are faster. Doesn't this work? Oh, it throws a red away. I see. Three nodes. Let me think. I guess I can do this. That also might be a little slow, but... Oh yeah, that's wicked slow. Okay, we need another decision tree here. Ow, ow, ow. Right? Something like that? I don't know. Will it be really smart about the reds or something? The reds that do get left behind? No, not quite. Well, it's sort of worked out, I guess. I guess it's not perfect then. $30,000 for a Viking helmet. Tambourine. Excuse me. Random forest. Scotch gradient descent. Isolation forest. Entourage. I guess I'll buy the plant. There it is. There's that raccoon. Hey, the raccoon. Let's save. Med-X or Illuminati Origins? Let's do Med-X. Greetings! Our company is manufacturing all organic natural painkillers. They're used to decrease suffering, mood improvement, and coping with eating disorders. Known side effects including dilated pupils, diarrhea, physical and mental addiction. Jeez. Caused by human factors. Known side effects are caused by the human factor. From time to time, our workers pick the wrong plants because they look like medical herbs. We'd like you to design an algorithm that would sort herbs by petals color. Okay. DLL editor. DLL is basically a sandbox for schemes. Create them, apply them in tasks, experiment as you wish. You can use almost all kinds of nodes. As many inputs and outputs as you see on the screen. Keep in mind that you only have one slot for DLL on them by default. Or they should have to get one. I see. Can I like delete these? Yeah. Does that work? No. It's kind of annoying. So here's the DLL editor. Let me go back here. Alright, we have to sort these. Ah, jeez. And I get 3 nodes. I could put it all into one editor, realistically speaking. RGGBRG. So I guess theoretically this is just 2 decision trees, isn't it? One here and one here. Or 3 rather. Like this. This is exactly what it would look like. So red and green need to go up. Red, many. This, I guess? This one isn't red. This one is red. It's like inverse. So like that? I think any here would be better. Then we do red. Also, yeah, sometimes it says red this way. How does this work? Blue? Red, blue? And red, blue? Like that? I mean, I guess that worked. I'll take it. I'm certainly no programmer, that's for sure. He's doing pizza. Illuminati origins. Good day. I study ancient manuscripts and books in order to figure out the true story behind the Illuminati's secret society. I need to recognize all the triangular shapes in these documents to solve the puzzle. You design a program, do it for me. Oh, I can do it for you, buddy. If you know what I'm saying. I didn't actually know what I'm saying. Sift, rather. This note compares shapes. Oh, we have shapes now. When an element's shape matches its designated shape, said element goes to the top socket. Others go to the bottom socket. Sift, in the real world, scale invariant feature transform. One of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. Sift is very fast and capable of recognizing simple objects and patterns. So let me read this again. Note compares shapes. Yeah, okay, it's a basic. We don't need to worry about anything else except sifting triangles. Just to get us used to it. 1.25 seconds is a very long time. Let me check my audio again, because it looks like it's boosted really loud. I don't just want to be shouting over this stuff, you know? Let's see. Something like that. 3-second delay. 1, 2, 3. Yeah, it is a little loud. guess it is a little loud in my head too. Let me turn it down a bit. Working for the man feels too easy. About 6 decibels. Shrank down. Working for the man feels too easy, boring or soul-sucking. Aim for the sky and become a CTO of a startup. In the world of savage market laws, it's either sink or swim. Will you get rich or bite the dust? It's worth trying anything. Almost machine learning. Basic machine learning. Neural networks. Startup. Cat overflow task. Task. Story comics. I see. I can buy a cactus. I can buy a tambourine. Increase data transfer speed by 1%. Oh, I see. I see. Socket processing queue by 3. Rentium. Node work speed by 1%. Data transfer speed by 1%. I mean, I might as well buy all the upgrades, huh? My guy isn't even at his desk. They let me actually bang on the tambourine. Spooky. Alright. Let's see. A letter from Mom and Dad. Hello, dear. Remember how you cherish your financial independence, but come on, your B-day is just around the corner. Be a good kid, take this money, buy yourself something nice, will you? We love you very much and we miss you. Don't forget to put a hat on, it's very cold outside. Give me $1,000. Thanks, Ma. Thanks, Mom, Pa. Right, let's save. I guess we can do Pizza Shack. Mama Smith's Pizza Shack. We're honored to invite you to join our startup, world's first AI-controlled pizza place. Fingers are always stained with flour. We can't write good code because of that. Help us write and implement an algorithm that would be capable of separating orders for round pizzas or for square-shaped pizzas. That's pretty simple. Simple enough. A scheme created while working for a startup does not differ from any other. There is no solution to startups. The scheme just works better or worse. And your future profits depend on the quality. I guess this is just a basic sift again. Round boxes. Square boxes. Program seems to be working fine. Further testing won't affect your results in the startup. Feel free to stop testing now. Trying to design an AI-controlled pizza place. It serves pizza in round and square shapes. Look at these machines. This one looks like it's ready to kill you. I kind of love these robot designs. The scheme you're designing is a brain of a pizza robot. So it operates your client's orders. Uses your startup, in this case, your pizza restaurant. Heard of the new amazing place in town. They want to grab a slice. These are your client's orders. The millennials don't care too much about the toppings. Only shape matters. Mind the accuracy. If the clients get the pizza they've ordered, they will pay you money and tell their friends about the place. If it doesn't get what they want, they refuse to pay. Don't expect them to return with friends. Clients don't like waiting in queues, and they will leave with no hesitation if your scheme is working slowly. Waiting line will get longer. The market is constantly changing, so pay attention to what's going on and experiment with your schemes. Now it's time to launch your first startup. Action deploys the code to the server. From this moment, the startup will work automatically. Let's get to business. This table is your principal source of information about your startups. When you switch the next day, you get money you've earned or lost, depending on how many users request for processing your scheme. Hey look, your users seem to like what your scheme is doing. They're even inviting friends. The cash is flowing. When the hype icon is green, that means your startup is all over the news. Expect lots of users. Patch. I don't know what that button means. Must be cash in. Today, your shares cost 600. You sure you want to sell them all and leave the startup? No. I see. I see what's going on. Alright. Pete's Jack. Pete's Jack. Excuse me. Alright, let's go to crowd psychology. Chicken Escape Farm. My name is Sarah. I own a small technology farm where distributors demand supplies of eggs of different kinds. It takes a lot of time to sort them out manually. We've decided to automate the process. We have all the data about egg parameters, but we need an algorithm which will work without human assistance, high accuracy. Okay, so I need to split them into threes. That's just a double. Like this. Here, circles go to top. Everything else to the bottom. Squares go to middle. Triangles to the bottom. Well, that's what that would look like. 1.238 seconds to process, though, is very, very long. Not gonna lie. Especially for on 6 for each. Yeah, I literally can't make it because I don't have, like, upgrades to get there fast. That's kind of funny. Crowd psychology is the last one there. Yeah, these things literally upgrade your stuff. 40,000 cats, jeez. Alright, let's hit it again. Crowd psychology. Our company is making a research on crowd psychology. We need an algorithm which would be capable of defining a person's type based on certain behavior patterns. This way we'll be able to quickly identify dangerous individuals in the crowd and prevent unpleasant accidents. Well, this is life. Ooh, I gotta do a double decision tree color and sift. Okay, so let's see what I should do. Let me think about what I should do first. Green triangle is the bottom. So I'll need a trash can. I'll need a couple of trash cans. I need to get rid of everything that's green that isn't a triangle. I have 6 nodes to do it. RB, RG, sort. That's a bit of a hint, isn't it? So I guess we'll start with a decision tree color. Bastards give me both, huh? Alright. So we'll go red, blue. Red, blue is easy enough to sort, I think. Green is the only thing that goes down, but red also goes down. So we'll send blue up top, rather. Then we need to sort it again. We should probably do green instead. Because, yeah. Green and blue. That way it's not a question of where red should, where red should go, because red needs to go to both. So then we need to sift shape. We need to delete some shapes. So let's see here. We plug this into here. If it's a circle, yeah. If it's a circle, it just goes in. That's perfect. Because that'll be blue and red. Everything else goes down here. If it's a square, it'll go in. If it's anything else, it'll go to the trash. Okay, and we do the same thing on the bottom. If it's a green triangle, it'll go in. Or else, it'll go sift again. I mean, this is the thing with nodes. I'm used to working with nodes in something like Blender and Unreal Engine and stuff like that, and that's the thing. Nodes can get very messy. Can I... Yeah, they won't let me add an extender. Maybe not yet. And a square, if it's a square, it'll go in. Anything else, into the trash. That... this also doesn't sift red triangles or green squares. This one down here, but I don't seem to have the extra node to make it necessary. Let's see what happens. Yeah, an instant red triangle into it. Doesn't look like it's damaging at all. We just need the goal to get done. That's the most important part. Oh, look at that sift. Yeah, it's got quite a bit of backflow, doesn't it? We're definitely not gonna match that that gold time. You ran out of time, low accuracy. Yeah. I guess so, huh? So, the blue-green split is correct. It's just these sifters are so... And I only have 6 nodes, huh? I guess I need to make a CST sift. That's circle square. I guess I can do that for the top one. That might save a node. If I do this, that counts as 2 nodes. Yeah, I don't really know how to speed this up. Everything gets bogged down around here, because it is looking for triangles. There are more triangles than squares. Throwing away the circles first would be best. Let me try switching these. See if that speeds it up. I don't need this. I can just recreate it. Circle in, triangle, square in, circle out. There aren't a lot of circles, there aren't a lot of squares. Maybe if we sift those first, triangles won't be such a problem. Yeah, my accuracy is definitely not very good. It looks like going squares first was a little faster. Might not even be able to do this yet because of the speed. ran out of time. Alright, we'll switch it around again. Let's see if it's any faster. This one down here looked like it got done pretty quick, no problem. I think. So what I can do is like, I can sacrifice accuracy for faster times by doing another decision tree color. Like this. And then just plugging them straight in, you know, I mean, I could just like, if red I can go there, and then I can just sift blue. No. Oh yeah, what if I just plug them both into this one? Yeah, like no accuracy. I can get the product done, but... yeah, but the accuracy is horrid. I still need to, you know, I'd still need to sift through all of them, so if I just plug them both in, I can finish it, you know, get paid, and then come back to it later or whatever. Like, yeah, this is pretty bad. I don't think they won't take it without 100% accuracy, it looks like. That's what the yellow marker means or whatever. Yeah. I think they'll take it without 100% accuracy or whatever. Alright, I think we'll have to come back to that later. If they let me. You've reached the end of the epoch. Click one of the banners to proceed further. Cold fusion. Bronze, silver, gold. Gold? Liza, first cat chatbot. I hope I didn't just... real life tasks. Good God, man. I hope I didn't just select the hardest difficulty. Because, like, I am by no means, like, a programmer at all. Even when it comes to nodes. Learn how to detect the cat in picture. Animal emotions recognition. Hey, so I managed to make my computer detect the cat, but that beast is a complicated soul. Definitely has more to tell. Time to go to the next level, start recognizing emotions. Ever heard of perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. Double helix, rock and roll, lava lamps. Switch to dogs instead of cats. Decision trees worked like magic for my Pluto. You can also hit the store and get that random forest node. Forest is more effective than just one tree, you know. Error rate. And now for something completely different. Perceptrons can actually learn and improve. Bad news, they also make a ton of errors on the way. The percentage of errors is shown on this icon. Use training mode to teach Perceptrons to decrease the amount of errors. Mark 1 Perceptron. In training mode, Perceptrons reduce the amount of errors while trying to predict the shape of elements. Test run, Perceptrons only predicts shapes. Interesting. Rosenblatt's Perceptron used in Mark 1. Perceptron could recognize only simple linear dependencies. It was enough to recognize English letters. So I just plug this in here, 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 and then I run a training on it. The nodes on the field have reached their minimum margin of error. There's nothing more you can teach it. So I suppose that's a 20% margin of error or something. So let's go through it then. Yeah, alright. I guess that was a 20% margin of error. 3,000? Woo! Time is passing by and the market changes. When hype icon is yellow, it means that your target audience is already aware of your startup. Don't expect many users at this point. When the hype icon is gray, that means that you've satisfied your target audience. Users are starting to leave. Watch your earnings carefully. When the number becomes red, it's time to cash out. Okay. I understand. Fade haircut. No thanks. Back propaganda poster. Data scientists as the world unite. Hell yeah, brother. Hell yeah, brother. Almost machine learning, basic machine learning, neural networks, load balancing, parallel calculations, self-driving car. Good for pictures, grandpa probably used it. Perceptrons. RL0. Tasks with real RL. Reinforcement learning. Hello, we as a society of peoples who loves cats. We wants our cats to have all of our best. We wants cats to drive cars with no humans instead. The cats have no hands, cats have paws. Can you make a car that self-drives? Yours, Dr. Meow. Cats, human person. P.S. Please excuse our grammar. We are not cats, we are humans, but we can't type well because of our paws and no hands. Terrible car accident, bad surgery is why I need self-driving cars. Haha. 200 gold! 200 gold! In reinforcement learning tasks, nodes work a bit different. All data is initially unspecified, and your task is to recognize it and transmit it to RL agent of the AI. SIFT object detection. It's the unrecognized data on the input and classifies them as either an object or as a road. Object to the upper socket, rows to the bottom. SIFs, scale invariant feature transform, is one of the most powerful non-neural yeah, we already read that. SIFT detection. So we just plug it in. And we plug it in here. I guess we plug both in? .2 seconds cost. Ooh, I see. Tune. On the screen, you'll be training and testing an AI. AI acts basing on data you've been recognized when building your scheme. Data about surroundings on the road are processed from your scheme to machine learning model. Your car won't be capable of learning and detecting obstacles without it. The goal is, in this type of tasks, is to make the AI clever enough to be able to reach the target's average speed level. Press supervised learning and drive the track yourself using WASD or arrow keys to teach the AI. Be careful, the car sees only objects inside a LiDAR. You can only learn from them. Supervised learning, so... yeah, okay. Press training and watch the car's AI trying to reproduce your actions. We hope you've been driving safely in that supervised learning stage. Evolve. Maximum number of epochs limits reached. Oops, you've reached your epochs limit, but your model isn't good enough yet. Epoch limit has been reset. Try using other data or parameters. Do. Something like that. Model has achieved the target speed level. Press test and enjoy your results. The result isn't good enough. Try training the car again. Okay. I see. Whew. Awful. It slammed right into it. Yeah, I guess that's good enough, huh? Let's release it. Parallel calculations, load balancing. Fascinating. So when this gets red, it's time to sell. Okay, let's do some test recognition. We are aware that you were able to create a text recognition system based on the Rosenblatt perceptron. We need a similar system that would also be able to distinguish vowels from consonants. Task is simpler, more accuracy is required. Rosenblatt perceptron. First perceptron machine neuron was invented by Frank Rosenblatt in 1957. Frank created Mark 1 in 1960. Mark 1 is a perceptron machine that can recognize English letters by their shape. So I do this, I do this, I do this. Can I split it or something? It won't let me do 2. I guess I just don't select it, huh? Can we train it? Up. That not work or something? I don't know, let's test it. 23%? That is within 75%, so... I mean, I guess it's fine. I guess it just... I mean, I guess you just... throw them wherever. I don't know. I don't get it. Oh, maximum, okay. God, that 20% is kind of a lot more than it looks. That worked okay. 94% accuracy, 87% accuracy. Okay, I mean, that's what they were asking for. So. Self-driving car. Parallel calculation. Still not red on the income. I think we'll do one more, and then I'll go to bed. Dairy products. Still need to do crowd psychology. Dairy product manufacturer. My name is Sam. I own a dairy product factory. My dream is to make the very best goods on the market, and that's impossible without high accuracy and fermentation processes. Alright, off with the fancy words. I want a program that would judge the quality of a product by its ingredients. We often make mistakes when doing it manually, and a lot of our products never leave the factory. So once we mark them as defective, we have the data, but we need the algorithm. Okay, so I can do this. Like that? Damn. Double Perceptron, they still fucked it up. That's pretty funny. Like, I guess that's technically correct, but 72% margin of error is pretty bad. I guess it is a 40% ask. Do. 66%. We could probably get it under 60 and be fine then. Just won't work out. It's just not doing it. 50% is fine. That's a little lower than I'd like, though. Or a little higher than I'd like. Yeah, we'll just go through all the data. Fuck it. That works for me. Do do do. Do 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 do. Yeah, probably could have ran it for a little longer, but it's fine. Metal Gear construct Metal Gear. Metal Gear. Alright, let's save and I'll be off. Not gonna lie, programming? Kinda boring. Take a nap, get out of here. Alright, thank you for watching today's stream. I'm sorry about the City Skylines stream. It just didn't work out for me. Maybe tomorrow or something. Because when I start streaming earlier, the internet just hiccups.